This is the Amp Hour Podcast, released July 9th, 2023. Episode 638. Building AR Headsets with Aedan Cullen. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Aedan Cullen. I'm interested in both the hardware and software aspects of embedded systems.
Well, then you are in the right place, Aedan. Thanks for joining.
Thanks for having me on the show. This is my first time on a podcast. I'm interested to see how it goes.
Oh yeah, well you're doing great so far. I've seen you on video. I think first and foremost, I think I was watching your Hackaday SuperCon talk. I actually didn't get to see it live. They started publishing all the talks, and I was like, wow, this is definitely something that I want to talk to Aedan about this stuff. So you were basically the title on your talk. Actually, I don't know the title on your talk, but you were basically talking about an AR system that you were building for yourself and for fun, right?
Yes, so I started getting into this project after previously being interested in software for AR, so all of the sort of SLAM and computer vision aspects of the problem. And at that point, I was in middle school and high school. There was really no hope of doing any sort of custom hardware. But then, when I got to college, I decided to, make an effort to learn as much about microelectronics design as I could and move as close as I could to this idea of all-day AR devices. So I just started prototyping and playing with hardware, and project has gone through quite a few iterations since then.
It's been consuming your life, huh?
Yes, it has.
As good projects tend to do.
Mm-hmm.
Yeah, so that's great. And you are on what rev would you say you're on now?
So the current board that I'm working with that we can talk a bit about, this is essentially the fourth major, I would say major redesign in terms of, starting from a blank slate and doing a complete electrical and mechanical design. This particular board I've now done a second revision of. My previous boards, some of them, just I produced one revision and then moved on to a completely new design idea. But it's been about a 4-year project so far with about 4 main design ideas.
Wow. Yeah, and I guess we should state as well. So, this isn't you're not a longtime veteran. You actually are a young pup in the world of electronics, though, making things that I'm pretty sure that in my 20 years of electronics I could not still do. So, you just graduated. Congrats on that. You just graduated college, right?
Yeah, thank you. It's definitely been exciting to try to get into the world of, boards that are more similar to what you'd find in a phone than what you find on an Arduino. Mm-hmm. And I suppose I found the augmented reality idea to be a good motivation for learning that, because everyone is designing phones nowadays, so it doesn't seem as exciting.
I didn't know that. Yeah, it doesn't. Who's everyone? Is this people at your university or just generally like out in the world?
Well, in the technology industry, right?
I see.
Every company has their phone design, and they can do that. So if you're trying to learn something new, at least for me, it's a lot more exciting to aim for something that no one really has figured out yet.
Right.
So that's why
like novel areas of inventiveness and where can you do something that's kind of out there? Yeah, that's a good point. What about your exposure to AR? Had you tried it previously? Like, what got you actually interested in that area?
I originally became sort of involved in the software aspects of it from my interest in robotics. So in robot motion planning and navigating robots, you have very similar, often SLAM and computer vision pipelines, tracking things using cameras, interacting with objects in a 3-dimensional space, modeling the world like that. So those computer vision, techniques led me to get this, back in, I think, 2015-ish, 2016, NVIDIA released their Jetson TK1 developer board. Yeah. So I got one of those and was playing with tons of computer vision stuff on it because, it was a great platform, that you could put on a robot, and that then, of course, people did put in AR headsets like Magic Leap with the subsequent Tegra SoCs.
Oh, I didn't know that. I didn't know that was what was in there.
Yeah, so Magic Leap, they're like light pack thing that you wear on your waist. At least it had in the first version. Haven't taken a look at like the new second iteration of it, but it had an NVIDIA Tegra SoC. So, yeah, really those computer vision aspects got me into it. I haven't really gone around trying a ton of, you know, existing AR hardware. That really wasn't my goal in it. My goal was
Hmm.
to, start and learn how I think that this sort of hardware has been developed. There are lots
Yeah.
of people who have, tried every headset on the market.
Right.
That's not me quite yet.
I feel like that actually sometimes that's better to not have done that up front too, because then it's not like how can I be so radically different from these other things? I mean, some of it you could like kind of get a feel for what's good, what's not, but sometimes then you feel like you can't repeat the stuff other people are doing as well, which could be limiting.
Right. I think in some regards it's helpful to have, a clean slate to start from and not compare yourself to a design that you saw previously. And then in some regards it's also helpful to be very aware of what already exists so you don't duplicate work and so that you make progress ahead that other people find useful.
Yeah, I've heard SLAM before. What does SLAM stand for again?
So that's simultaneous localization and mapping,
Aha.
which is this sort of computer vision topic of taking one camera, multiple cameras, perhaps other sensors like IMUs, and tracking the location of this camera unit in space. So mapping the world around you as you track your motion through the world. So that's really the technique that you find used on a lot of these headsets to locate the user in space so that the graphics can be rendered according to their surroundings. In a lot of cases, that may not even be necessary if you don't need to have objects anchored to the real world. But that was kind of the
Right.
bridge
Right.
between robotics and AR that I found.
Got it. Yeah, that makes a lot of sense. Yeah, because I okay, so I was a glass hole, and those things were not locked. Those were locked to just like your field of vision, basically.
Hmm.
So as your head moved, the whole screen moved. But
Right.
you're saying that on certain things like Magic Leap, where you're trying to like have a little animated clown dancing on a shelf in front of you, you have to first detect the shelf, like visualize a flat surface, and then re-render this thing to be dancing on that flat surface. That kind of idea.
Yeah, exactly. So there's essentially an entire spectrum of design choices you could make in this field that is currently called augmented reality. And I think people are going to have to find better names for things, specific devices in the future, because there is a huge difference between something like Magic Leap or the goals behind HoloLens, these large devices, well, and Apple Vision Pro now, where the goal is to be able to produce this 3D immersive experience. There's a
Yeah.
huge difference between that and something like the Vuzix devices or the prototypes I've been doing, where the goal is more to get a really low power, lightweight device with simpler graphics, perhaps just 2D graphics.
What is the Vuzix you mentioned? I've never heard of that one.
Vuzix is a company that they've been doing quite a few sort of smart glasses devices for enterprise applications.
Hmm.
Most of them run Android.
Okay.
So if you look at teardowns of them, they're essentially more or less an Android phone stuffed into a pair of glasses. And they do applications like
Yeah, surgery. It looks like.
maintenance and such where
Yeah.
you want to have your
Yeah.
hands free, right, and view reference information or telepresence video conferencing things.
Got it. Yeah. So yeah, I can imagine that's the one that I always think of actually is that maintenance application where it's like they're looking inside a turbine. There's some kind of like QR code that like locks you to a frame of reference, and then it's like doing overlay arrows and being like, oh, you're going to change part 74 now, and here's what's highlighted and overlays that sort of thing.
Right. Yeah. So there, Vuzix is going for those sorts of applications.
Got it. Okay. Cool. Cool. That's good to know. Okay, so that's kind of the space that we're in.
Mhm.
And then you had mentioned that you are not playing in the super high end kind of. So you are maybe locked to a thing in space, but you're not necessarily trying to make it immersive in that you're not like. So I guess Vision Pro is probably a good one to talk about, right? That is like a basically a. I think of actually like a VR headset where they just happen to pass through the outside cameras. That kind of feels like what that is.
Right. So my designs that I've been doing are monocular displays, so display in one eye, intended for two-dimensional content. And of course, you still have the potential with a monocular display to anchor the content to the real world, have it change as the user rotates their head. But yes, it's a totally separate and opposite, design goal from what you have with Vision Pro, where the goal is to have this sort of large, very powerful, immersive headset. And yes, then you just happen to have the pass through. What I find interesting about this low power mindset is that it's much easier to imagine how you could get to something that someone would actually wear all day. If you pursue low power designs, applications like the Vision Pro and these immersive VR oriented devices, you're certainly not going to be wearing them for more than a couple of hours. But if you are just powering one display rather than two, you have, limited compute on board, but perhaps you can still provide a decent two-dimensional display, then you can start to imagine, how to get to something that you could actually comfortably wear. So
Yeah.
that's the direction I've been going.
Got it. So more akin to the Google Glass of the world's, the look through, the contextual information that you might be able to have, that sort of
Right.
thing.
I think, in my view, the shortcoming of Google Glass and a lot of the Vuzix designs as
There
well.
were many. There were many.
Right. One of them that I was particularly interested in was display resolution. Most of the
Mm,
devices you find that Vuzix is making and Google Glass had relatively low display resolutions, around
mhm.
640 by 480 pixels, sometimes even lower than that. And I wanted to try to get a high resolution display, at least something like 1280 by 720, or now I have a full HD display in my latest design.
Oh wow.
I wanted to try to get this sort of high resolution display in a lightweight, low power device, because my goal for the use cases I would like to see is to have, phone style applications on this wearable display in a
Mm.
lightweight device. So you still have a comparable number of pixels to your phone, and you could fit that sort of rich content that you expect.
And are you still thinking about? Would it still also have like inside out cameras, like looking out to view the world and do that slam type of stuff, or is it more just locked to the face right now?
Essentially, the challenge with SLAM and cameras in general with my designs is just power consumption, because you don't want to spend too much power on processing for these sorts of computer vision tasks. So the question ends up being, what is worth spending power on? What would improve the usability of this device and what wouldn't? So, these current designs I have, my latest prototype supports one camera. So the question is, you could point it at the user's
Yeah.
eye, and detect blinks, potentially, track the direction that they're looking for input, or you could point it at the world. If you point it at the world, the processing on board this device, is a microcontroller style system. It's not necessarily the best thing in the world for doing something
Right.
complex like SLAM.
Yeah.
So there's sort of that trade-off to deal with. You could feasibly do at least simple optical flow stuff for tracking translation of the user in
Hmm.
space with this camera system I have. I haven't gotten into the software of doing that yet. I mean,
Right.
the SoC I use has a DSP as well as a Cortex M33. So you could program the DSP to, offload some of that vision stuff.
Okay, that's great. That's great. Okay, that's actually a good segue. Let's go back to the previous version you talked about in the talk. We'll obviously link in the talk, the Hackaday article, all that stuff, so people can watch kind of the rich detail view and stuff like that. But can we just talk about the system level design of that one first, and then we'll work our way towards the more the most recent prototype.
Right. So that one used, well, at that time it was a bit newer, but Allwinner had released their RISC-V chip, which they called D1. And I, seeing that and being interested in RISC-V, I was, immediately interested in doing a design with it. Now, that particular system on chip, they include quite a few nice video processing features. It has H.264 and perhaps also H.265 decoding and encoding on the chip. It has MIPI DSI outputs. It also has LVDS outputs, which were important for the display I was using at that point. So I wanted to do a design with this all-winner chip because it seemed well suited to my goals of having good display capabilities. I could integrate it nicely with the Sony display I was using and fit it in this small form factor. They took the same chip that's well, the die in that D1 package. They also package it with integrated DDR2 in that D1S package, which is also called F133 because they have duplicate names for some reason. So yeah, I used that. I used that package with the integrated DDR2, which is of course a, it's nice because it's, easy to work with and low cost.
Hmm.
The system in package concept is very helpful for doing miniaturized
Yeah.
designs like
Yeah.
this.
Totally. Yeah. And I honestly, like, if you look at modern, you brought up phones too, but like those are all super stacked up. You look at an iPhone, like just they're stacked chips on chips on chips, and then finally they touch down to the PCB where they need to talk to another subsystem, basically.
Right. So previously, even before that design, I was interested in system in package. There's this company in Texas, Octavo Systems, who
Yeah.
have kind of been, they did sort of beagle bone on a chip designs of sorts, right? It's an entire beagle bone black, essentially in a package. That was sort of their first product. And then they moved on to doing the ST Microelectronics STM32MP1. So they have a system in package with that. So previously, I did a board with that chip on it. I didn't show that at Hackaday SuperCon. But those processors are nice for sort of industrial control and those sorts of embedded applications. They don't
Hmm.
have great video capabilities.
You're talking about the Octavo specifically?
Yeah, the current.
Oh, I was gonna say those were huge when they first started doing those. They were like 0.8 millimeter pitch BGAs, right? They were big.
Right. So they still have large BGA pitches.
Hmm.
So they're still easy to work with. Yeah, the SoCs they're putting in them currently aren't really multimedia focused because that's not exactly their target
Hmm.
customer right now, as
Yeah.
per my understanding. So I used those in the past and I like them a lot. For what I showed at SuperCon, though All Winners stuff is terribly documented, that was, a, a more exciting choice for my display application at that point.
Yeah. Totally. Okay. So just to wrap up the system view here. So we have a display from Sony. We have this D1 system in package from Allwinner with DDR and the RISC-V processor.
Mhm.
What about other, like, battery charging? What else? What else is there? I mean, it sounds like that's the core of the thing, but what else is there?
Yeah, so there's a single cell lithium ion polymer battery charger. That's just a typical linear battery charger. And then there's Wi-Fi as well. I'm still using the same Wi-Fi module from Silicon Labs that I put on that design, which is
Hmm.
quite nice because it has good sleep modes and low power consumption in the sleep modes. So that's why I had chosen it. I was choosing Wi-Fi over Bluetooth
Hmm.
because of the increased data rates, because with Bluetooth,
Yeah.
having a practical limit of 1 megabit per second or less for throughput, that's pretty limiting in terms of sending content to the device. Because since I have limited processing on the device, providing
Yeah.
content from a phone connected over Wi Fi or some server on the internet, that's a big opportunity for improving the capabilities of the device because you have
Mhm.
limited compute on board.
Great. That's good to know there. What about other things? So interconnect, other power handling. What else? What else is on there?
So the most of the interesting design challenges came with the display. At that point, I was using this display from Sony, the ECX 337. So that requires, 10 volts analog power supply. So
Oh,
there's,
really?
boost converter for that, a few other random power management things. I was using on that board these little sort of they're like co-packaged inductors with a
Hmm.
boost, well, inductors with a DC-DC converter IC, a buck
Uh huh.
converter under
Yeah.
them from Torex Semiconductor. So they're these nice little packages. They basically have the inductor stacked on top of the
Hmm.
chip. So it provides a really nice small footprint DC-DC converter with pretty good efficiency. So I was using those around the entire board for various power supplies and such. The Sony display, it's 10 volt supply and it has this LVDS video input. That's kind of the most annoying part about the Sony displays. They're not using MIPI DSI inputs.
Oh,
So
okay.
you either have to have LVDS outputs on your SoC, which the Allwinner D1 does, or you have to use a bridge chip. So previously, when I did a design with Octavo's system and package, the STM32MP1, I had, parallel RGB signals going to a bridge chip, to
Mm,
LVDS, then to
yep.
this Sony micro display. And of
Mm,
course, the bridge chip occupies board area, consumes power. It's just, an annoyance to design around it.
yeah.
So then you start deciding to just choose SoCs with the correct display interface already and not bridging it.
Yeah. Yep. Yep.
But I mean, LVDS, I suppose, is technically the better name is FPD Link, which came from TI and National Semiconductor, I think, but it's, kind of old. Not many people are using it in mobile devices currently.
Yeah, it is interesting hearing. Like, I mean, what that sounds to me like is like, so you chose the display for its specs, for its size, and then that just like had this cascading effect throughout your design, which is, I feel, super common. You know?
Right. And in this case, it's like that because of the miniaturization required, right? I
Yeah.
don't want to
Right.
spend board area on a bridge.
Yep.
I don't want to deal with routing it. It's too much of an annoyance in this tiny form factor I'm going for. Yes.
Hmm, interesting. Okay. So then, so you got the board. This is what your talk's about. Did you get all the way up through sending data? I mean, able to send data, able to send images over Wi-Fi?
Yeah, so I've been doing also currently a lot of work in figuring out the most efficient ways to do that for user interfaces, because of course
Mhm.
you can easily just stream video over Wi-Fi in the standard ways people will do, just
Mhm.
taking a transport stream and throwing it over the network. But then, of course, maybe you want to turn the display off sometimes. You want to start and restart this. You want to maybe not send entire frames, just refresh part of the display.
All right. Yeah.
So at that, I've kind of had this trend of finishing a hardware design like that, then working on the software and then wishing I had different hardware, right?
Oh yeah. Yeah.
Because you're
Yeah.
you're always thinking of what could be better and what could be next. So
Yeah.
it would certainly be nice to eventually get more people developing software for this, because I just keep going back to doing another hardware revision.
Right.
So I mean,
Totally.
I didn't spend too much time doing like application level software development for that,
Mhm.
beyond bringing the thing up and getting stuff running on the display and such, because then I was on to another hardware design.
Yeah. It is an interesting idea to kind of just almost have a mirror of like you could have like a Wi-Fi connection and then stream like a mirrored view of a computing device, like a laptop that might be, sending stuff over Wi-Fi as well, because then it becomes a computer side software problem versus a display side problem. Like it feels like a lot of the, again, my main context for all this is Google Glass, but they
Mhm.
used an OMAP on that, right? That was the
Yeah.
TI chip
Mhm.
that's in the Beagle as well. And like they basically rewrote, I mean, they basically wrote a quasi Android thing for that as well, where they're all cards and it's all embedded processing. If you wanted
Right.
a new feature, you had to push firmware down to it, and then it could talk over Bluetooth to your app on the phone, sort of thing, instead of the phone just doing the heavy lifting and streaming it up to the device.
Right. Yeah, I think offloaded processing to a laptop, if you're by a laptop, or your phone if you're walking around, I think that's going to be a big trend in these sorts of designs, because
Yeah.
people do want to just put a low power, microcontroller or very basic Linux system into something like this without
Hmm.
spending too much power on doing a very complex OS. At least people who are interested in this sort of low power all day wearable. Of course, if
Yeah.
you're doing a
Right.
big, bulky thing that you don't expect the person to wear all day, then you have tons of leeway.
Yeah. What about power? So let's talk about power too, because again, my Google Glass had like a 400 or 500 milliamp hour battery on it, and it didn't last.
Yeah,
But I imagine Wi-Fi streaming as well as even in low power Wi-Fi is there's just a lot of electrons flowing around here.
yeah, yeah. That's really a challenge with choosing between Wi-Fi and Bluetooth as well, because
Yeah.
using there's not really a very satisfying low power personal area network, beyond Bluetooth, if you want
Hmm.
higher data rates, because Bluetooth is great for low power consumption, and like Nordic's NRF series of chips are
Hmm.
awesome for that. But if you want to transport Wi-Fi over it, Bluetooth is not. Sorry, if you want to
Right.
transport video over it,
Video. Yep.
Bluetooth is not the best link to choose for that. Then you're forced into Wi-Fi, and yes, then you have this sort of order of magnitude power consumption jump.
Yeah. Right. My friend actually was at a startup that did that. They basically tried to do. They I mean they successfully did video over Bluetooth, but
Uh,
they didn't abuse the spec, but they basically kind of squeezed a lot of efficiency out of the spec because it's just like not what Bluetooth is designed for, right? And even then, it's like low bandwidth, that sort of thing.
right, it's not what it's designed for. And I suppose in this area, you can make a lot of progress in some cases by using things in ways they weren't
Yeah, right,
intended to work.
right.
On the display side, I've also been doing that a lot recently with this other non Sony display that I switched to using.
Hmm. Okay. Yeah, no, so that is interesting about that. I mean, that I think just packaging up frames and sending them over Wi-Fi is an interesting idea. But like we said, like the power is a concern. What was the battery size you were kind of targeting, and what was the relative? You said an all day device. What is how do you kind of define that or benchmark it?
So my goal now is for most of the power consumption to be in things like the display and Wi-Fi. So I want to try
Okay.
to minimize power consumption in processing. So that
Okay.
design that I was showing at SuperCon doesn't really align with that goal yet, because just running that chip with the DDR and running Linux and power management for the RISC-V core, all that stuff consumes more power than I would like. I since moved to doing really low power microcontroller systems with the goal of having the display and Wi-Fi data transport being the main consumers of power. So then you only want to consume power in that view on things that are facing the user or delivering content to the user. I want to try to get as much processing as possible off the device so you don't have to spend much power on that. So with that sort of mindset, when power consumption is dictated by the display, then it's really the type of content that determines how long you can run it for. Of course, if most of the pixels on the display are off, in these OLEDs, then those pixels are not consuming power. So if you just have
Mhm.
some small UI, floating in the center of the screen where those pixels
Right.
are on,
Right.
then the display consumption is pretty low compared to the maximum if all the pixels were white. So I want to be able to, eventually get to the point of, 8 hours or so. That's what I considered all day with that sort of lightweight information. Of course, if you decide to, mirror your computer screen in the
Yeah.
inference
Right.
use cases, it's hard to get, a solid 8 hours, from a display that's fully
Right. Without
operational.
having like a hip backpack of or a hip pack of batteries or something
Right.
equivalent as well.
Yeah.
Right.
The design I had at SuperCon had a 500 milliamp hour lithium ion cell.
Hmm.
And then the prototypes I'm doing now, I'm trying to, cut that down to more around 200 milliamp hours or so.
Oh. Okay. Yeah. That's great. No, that's a good kind of. I think that's the thing where like you're like you said, you started from a blank page, and one of the problems there is that you're defining your own specs as well, and we haven't even talked about like cost and the requirements you're creating for yourself. Sounds like they're very reasonable, but they are also for a user of one versus if you were like making this a product. So just thinking about like the kind of the requirement space that you're creating for yourself, it's interesting to hear your process around that, honestly.
Yes, I suppose in in my more recent design since SuperCon, cost became more of a consideration because this was my first HDI board, and so it was a sort
Right.
of
Yeah.
unknown area in terms of fabricating things. For my design that I showed at SuperCon, those were also the first boards that I did full turnkey assembly and just had a contract manufacturer build them for me,
Yeah.
because at that point I had kind of become tired of the stress of hand assembling,
Hmm. Just
0402s,
wanted to make sure that
0201s.
like I put enough flaws into my own designs. The soldering doesn't need to be one of them. That's how I think about it.
Right. Right. Yes. And then I wasn't going to try, I probably should at some point, but at that point, I didn't feel like spending the time, assembling 3 or 4,
Yeah.
zero point
Yep.
0.4 millimeter pitch chip scale packages on this board.
Well, and yeah, and you should eventually, but after you have a working unit, like a golden unit that you can compare against, you'd be like, oh, this isn't like some. If you do it on your first board, it's like, is it the soldering or is it the code or is it something else? Like if you at least have one working, that's a good starting place. I feel like.
Exactly, yes. So, fortunately, these first prototypes that I did earlier this year for this new design, they did essentially completely work on the first revision, which I was happy about.
Yeah.
And given that there were some things on this board that were not tested on like a larger evaluation style platform first, kind of the particular risk that I took with this design was with this new display I chose, which is a MIPI DSI display, and then I'm connecting it to this SoC from NXP, which also has a 2-lane MIPI DSI interface. The really interesting thing to talk about with this design is the fact that the display is not really supposed to support 2-lane MIPI DSI. They intend to use 4 data lanes or 8 data lanes rather than 2. So there was a kind of interesting roller coaster ride in
Stress.
right, roller coaster ride in configuring the display to work in this
Oh.
system.
Could you explain the lanes thing? Because
Yeah,
I'm not a display person. I don't know if I've ever done, aside from like hooking up a CM4 on a project. Like I've never gotten that stuff. I've never dug into it enough that I've needed to do this sort of thing. So what do the lanes refer to?
sure. So in MIPI DSI, the display serial interface, the data is transmitted as, a serial stream of bits over these differential pairs. Each pair transmitting data they call a data lane. So typically, like on the Raspberry Pi's connectors, you'd find 4. So 4 bits are being transmitted in parallel, and then of course, in a large serial stream overall. So there are 4 differential pairs for data, 1 pair for the clock signal for the high speed clock. And most displays, for the typical DSI standard will run, those 4 data lanes at around 1 gigabit per second. And you can get, full HD at 60 frames per second through that just fine. But then, some displays use more non-standard configurations. In some like watch designs, you'll find people with 1 data lane for their MIPI DSI interfaces or 2 data lanes.
Hmm.
So in this design, I was really interested in using this chip from NXP, which is part of the IMX RT family. So these are kind of high-end microcontrollers with
Yeah,
some
they're beefy.
nice graphics capabilities as well.
Yeah.
So this chip I'm using is the RT500, and when you look at it, your first thought is this is designed for Garmin because Garmin has been using NXP microcontrollers, well, previously Freescale, in their watches for quite a while. And this particular one has 5 megabytes of SRAM on board. So,
Wow.
that's
For a micro. That's big. Yeah.
right. And the reason it's there is for a display frame buffer because Garmin puts these in their devices and they don't have external memory, but they still want to be able to drive reasonably decent displays over MIPI DSI on their
Mm,
watches.
got it.
So
Got it.
it also turns out this is a nice fit for what I'm trying to do. I also
Mm.
want to have reasonable display capabilities. It also has like a simple 2D GPU and such in this really low power, small package. So it has, 2 MIPI DSI lanes out, right? And this particular display I'm using, you go ask the manufacturer, can we use it with 2 lanes? They're like, no. So,
Real quick on the lanes thing too, just to do some additional math
yeah.
on like board layout and stuff like that.
Mhm.
So you said most displays will do 4 lanes at 1 gigabit per second. So that would be 8 conductors for those 4 lanes because they're differential pairs, and then an additional set of conductors for a clock. Is that right? So 10 total
Right.
conductors.
Right.
Okay.
Yeah. So that's what you'd typically find.
Okay. And that's at 1 gigabit per second on each pair, but
Mhm.
there's 4 lanes being 4 bits. So is that an equivalent of like 500 kilobytes per second? Because that would be double. There's like a nibble.
You have essentially 4 giga nibbles per second. Yes, I
Giga nibbles per
suppose.
second. Oh, I like that.
If you want to measure it in nibbles, yes.
I have to make the name of the show that's something that like makes people understand who you are and what you do. But if this
Mhm.
had been a normal amp hour show, giga nibbles per second would totally be the title.
Yeah, that's very nice.
Yeah, yeah.
Right.
Okay, great. So then when it gets kind of decoded on the display side, then something you have to do inside that display tells it, I'm sending you 4 lanes or 8 lanes or whatever the available things are. Here's how you kind of unwind that to get the data into your localized memory. Is that how it works?
Right. So some displays you can't configure the controller IC to use, a different number of lanes than, really was intended. So some you find, can be switched between 4 lanes and 2 lanes. Some are only intended to work with the standard sort of 4 lane setup. And these display controllers can sometimes be annoying to deal with because, of course, they have tons of registers for configuration, and the documentation of what the registers do can be quite hit or miss. So, like this particular,
Got it. Because these are like a custom silicon, often out of China sort of thing, where you're usually working with an FAE or something like that. But if you're not, then you don't have someone to just set it up for you.
right. Yeah. So, this particular display, it's a silicon backplane with the OLED structure on top of it. And then this silicon
Cool.
backplane has the driver IC on it. And then
Okay.
this driver IC is responsible for, taking those lanes, shuffling the data around, and then, driving the actual array of pixels. And, there from this particular company, this company is Vutrix Technology, who makes this display, particularly
Do
the backplane they design.
you think they say
They're
the name out loud before they decide this is going to be the name of the company?
yeah, I don't know. I mean, yeah, they have a website which sometimes loads and sometimes doesn't. Vutrix.com, Viewtrix. Yeah.
Wow.
So yeah, this particular display, there are 8 data lanes in hardware that you can have because they want to be able to refresh it at like 90 hertz and such. But then you can also run it with a typical 4 lane interface. And the interesting thing about it is you can configure it to only refresh parts of the panel. You don't have to send an entire panel's worth of data to all the pixels at once.
Hmm.
So there are registers that can configure it for 2 lane mode, but I had to poke around quite a bit in order to find where they were and, email back and forth with Vutrix.
So basically, it's beg for help as a small time person, but then sometimes they do help.
Right. So yes, sometimes they do help. I mean, at first I was sort of reverse engineering the thing and I dumped out all the registers and was trying to look, where can I flip bits and potentially make this happen.
Hmm.
Eventually they did help me enough to get it to work.
Got it.
But then, there were since the display is so poorly documented, there are essentially an entire separate, set of problems in getting the microcontroller, the display controller in this MCU to talk to it
Hmm.
because of just all the other considerations and how this data is formatted. Some displays like require you to keep the clock running during the blanking periods. Some displays
Hmm.
require the clock lane to be put in the low power mode during the blanking period. So you have to like figure out what the proper configuration
Yeah,
is.
it's like the magical sequence of all the events you have to do, right?
Exactly. Yeah. So
Yeah.
in this case, NXP's driver didn't support putting the clock lane in low power mode
Yeah.
during the
Right.
blanking period. So like I have to go and, add that. This is in the Zephyr real-time operating system.
Oh, it's in Zephyr. Nice. Yeah.
Yeah. Yeah, so I've been using Zephyr for this, which
That's
has been
cool.
quite
That's
fun so far.
good promo. Okay. Yeah. Yeah, that's great. Okay, so now you have this. Okay, so you have this new processor, the RT 500, and if people don't know, the RT 106X, 1062, I think, or 1064. That's what's on the Teensy 4. So that's the
Right.
size, that's the beefiness of those processors. They're called crossover MCUs, and I know some
Yep.
of that team. Yeah, no, it's definitely it's got some heft to it. That's great. So now you have a 2 lane setup to the screen. What does it take to actually like write a driver that makes it all kind of go?
Well, of course, NXP already have, in their MCU Expresso sort of SDK, they have drivers for all the peripherals on this chip. Often you find things that weren't completely thought through for the particular application you're working on. So, of course, one of those is this sort of configuration detail I had to deal with. Zephyr is also kind of a young project in the sense that support for those NXP chips is kind of developing as we speak. The
That's right. Yep.
particular driver for the display controller on this chip, this DC Nano display controller, just showed up in Zephyr earlier this year. So you end up, poking around a lot as things change in order to get things working how you like. So, there were some, minor bugs in terms of managing frame buffers and things like that. So I haven't, done complete drivers really for anything in this system yet, because NXP did a lot of that work.
Hmm.
But you have to be willing to dig into the details to fix problems. I suppose the one unsupported thing currently in Zephyr is the GPU.
Oh, yeah.
GPU driver, I don't believe, has any sort of integration with Zephyr. So that will be the next step, and that will be fun.
And what is that? So, I hear GPU a lot in that they get repurposed for AI crap, but in
Uh,
this case, the GPU, is that to process the frames that you're kind of sending out to the display? How is that actually used in a display context?
so in this SoC, there are kind of, well, I would say three parts at work in this sort of, well, four if you count memory, in this typical display sort of setup. So you have the actual display controller itself, which is a block, connected to connected to a bus in the SoC, so it can access memory. It can go read the frame buffer from memory, and then it formats that, with the proper timings, sends it out to the MIPI DSI PHY, which then transmits it to your display. So you have the display controller. Its job is just to, pipe frames out to the display. Of course, you have the CPU, managing the display controller, setting all of this up, potentially touching frames in memory and whatnot. There's the memory itself. And then over on the side, you have the GPU. And the GPU in this system is from Vivante, now called VeriSilicon. I think they were like acquired. And it's called
More great
it,
names. More great names.
it's
Yep.
called, well, it's one of the GC Nano series. I think the full name is like GC Nano Ultra Light 5 or something. Yeah, it also has like a numerical name, GC, and then three numbers. I forget what it is. But it's
uh,
essentially a small 2D GPU intended for vector graphics.
okay.
So it has some like limited 2D rasterization capabilities, but it's supposed to support OpenVG, I think 1.1 or something. I'm not totally familiar with the OpenVG standards. It's meant for those vector graphics applications.
And so these exist. So it has a different brand name, but it exists in inside the silicon that you're already using, right?
Yep. Yeah. So NXP, of course, goes to them and uses their IP in
Ah,
the
okay.
silicon. Yeah.
Got it. Oh, okay. So it's like a partnership type thing or whatever, and then eventually NXP will buy them. Uh, it's
Maybe.
as large companies are likely to do. Yeah.
Yeah. I mean, you find that with a lot of blocks in these SoCs. They're designed by other companies other than the SoC maker, and then they get dropped in. So, like the
Hmm.
display controller itself is like from the same family of products. It's called DC Nano. Um,
Hmm. I thought DC. I thought it was the name of the display driver. Is that different, or is that the same thing?
well, DC Nano is the name of the IP block which does
Ah.
the display control. Then of course there's a driver which is the DC Nano driver,
Oh, got it.
which
Okay.
NXP has put together.
Yeah. Hmm. Interesting. All right. So 2D GPU in this case would be like, would that be to create animations that overlay on top? So a GPU in that scenario is being used to actually process. I'm really out of my element here, Aiden. So like, what does a GPU do?
So in this sense, the 2D GPU they intend for doing sharp text rendering as
Uh huh.
vectors, right? So
Okay.
if you want to do text that you can scale to any size, have it look clean, you can render that really nicely. Of course, you can do arbitrary paths, filled shapes, other sorts of you know solid colored UI elements with various outlines and shapes like that. In terms
Ah,
of raster stuff, if you have bitmaps, you can transform them, do all sorts of rotation and scaling stuff. So it's meant
got
for
it. Okay.
producing the sort of GUIs you'd find on a smartwatch, where maybe you have some buttons, some text, some small icons.
Okay. So then how does this all translate to, so if it's the 2D GPU, but you're going to be pushing actual like fully formed frames over Wi-Fi? So like what is the connection there? Like how does that all, how would you be able to use a GPU if not in those like vectorized ways?
So that's a good question. And that's to some extent still, an open question. How do you best utilize this sort of on device processing with content sent over Wi Fi? So that's definitely a question I'm still thinking about. With
Okay.
the transformation that you can do on the GPU, of course, you can imagine things like when the user rotates their head, well, you potentially want to move the content very quickly, transform it so that it appears to stay in a
Oh.
certain place. And
Uh,
that, those sorts of very fast closed loop interactions between, motion to a frame on the display, those have to be done on the device. So
got
you
it.
could, you can certainly use the GPU to shuffle things around like that, even if it's not producing
Got it.
the actual sort of rich content. And then, how you encode or compress this content to send it over Wi-Fi is another, question. And
Right.
some people will do things like just, simple drawing instructions, like put text here, put vectors, here, draw this path, right? Pipe those over Wi-Fi, have the GPU draw it on the device. Of course, the advantage there is you use your nice little GPU. The disadvantage is, well, now you have to program in this,
Yeah.
language
Right.
of your small GPU rather than using what you have on your phone.
Got it. Okay, so let me paint a picture for listeners then maybe. Okay, so we're watching an episode of Rick and Morty on my computer and I want to push it to my iDisplay. What are you calling this thing by the way?
It doesn't really have a name yet. I mean,
Have you have you thought of Viewtrix? Oh, it's taken. Darn.
yeah,
Uh,
I just have like random numerical, code names for my boards to keep track of them, but I don't have any flashy marketing style names yet.
all right, we can do a contest as part of the Amp Hour episode if you want, and it would be called
Mm.
probably viewing view face or something like that, right? Uh,
Yep, yep.
That's how it all goes. Okay, well, whatever this thing is going to be called. So I'm watching a Rick and Morty episode on my computer. I'm like, all right, I want to switch it to the eyepiece. Now, something on the computer packages up an individual. So it's like watching it 30 frames per second, frame 1 out of 30 in a second. It packages that up, sends it over Wi-Fi. The device gets it, and then it can like transform it, like almost like a flip book of JPEGs. Is it coming through how little I know about displays? I hope it is.
In reality, compressing video is a lot more complex than that because you
Okay.
want to
Okay.
be able to handle similarities between frames and take
Ah, right.
advantage of
Yeah.
those to reduce the
Yeah.
information you have to transfer. So that's
Mm,
already all, handled by very smart people designing codecs,
got
like
it.
we know with H.264 and H.265, AV1, all the fancy codecs, which I know really nothing about how they work.
Okay.
so so those are very impressive at what they accomplish. In this
Okay.
particular piece of hardware I don't have a hardware decoder for those codecs, right?
Ah,
So, decoding them in software is not feasible, on a microcontroller. So, my goal essentially would be to come up with some other, lightweight forms of compression for simple graphical content so you can still pipe that over Wi-Fi. So
mm.
you wouldn't expect to be doing full, complex videos with, you know,
Okay. So watching
very
Rick and Morty on my little
yeah,
display might not be the right fit for this
right.
device.
Watching movies is not really the intended application. The application would be, graphical user interfaces and such, where you may be able
I
to
see.
compress them more effectively,
Got it.
taking advantage of the fact they have these structured elements.
Okay, so more like the heads-up display that Tony Stark uses in the Iron Man film, something like that, where
Hmm.
it's like a graphical thing that's a part of the screen is not sending everything. That sort of idea.
Right. Yeah, I'm not a big movie person, but yeah, doing sort of, assistive user interface overlays.
Right.
That's the goal.
Right. That's what I was doing instead of you know doing this kind of design in my free time. I watch movies instead of this.
Uh,
I can imagine the stuff you're doing takes a lot of time though. That's it's very impressive.
yeah, it does.
Yeah. Okay. Cool. So in that case though, so what is actually sending? Is there like a helper program that would be on the computer or the phone? Is that the idea?
Right. Yes, you need a helper program like that. And
Okay.
I've been working on some things pretty similar to that. And of course, the disadvantage there is, you consume some extra power on whatever device is transmitting this data. So you're saving power on the actual wearable device, by doing this concept of transmission over Wi-Fi. But then, your phone's battery life is going to have to take a bit of a hit.
Yeah.
But
Right. Right.
these are the trade-offs we have to deal with, trying to
Right.
make any
Totally.
progress in this
Yeah.
area.
So then, do you create like either on past versions or visions of this most recent version? Do you create like a simulator to kind of I don't even know what it would look like honestly. Like what how do you prototype stuff before you actually send it down to the device?
You mean prototype this sort of processing?
Like what what a single frame would be. So if you had like a HUD style kind of like a heads up display type frame that you're going to send
Mhm.
over this link to this device, how do you know what it's going to look like? How do you code that up, I guess, on the computer side or on the phone side, and then kind of visualize what it's going to look like when you view the world? Do you build a simulator first?
So like I don't have a simulator of that sort yet.
Okay.
The optics on the device are definitely a big challenge in making things look nice, determining how things are going to look.
Mm-hmm.
And that's really still a big area of exploration for me because I'm not a big optics design person.
Mm.
Currently, the display in this device is oriented, as a typical 16 to 9 ratio landscape display.
Uh huh.
So if you have content that, fits that sort of form factor, of course, you could also put it in portrait orientation. You could expect it to look, reasonable just prototyping it on your computer screen. But in terms of like the actual usability of this, in the real world, you have to, certainly wear the device and try it.
Yeah.
Um,
Right. Okay.
and
Hmm.
that also comes into the mechanical designs of it, where the display is placed, whether it's comfortable to wear. There
Right.
are all these problems. Yep.
Right. Yeah. That's definitely interesting challenges. I mean, like, I guess one use case that I've seen a similar thing in the past, and I mentioned before the show, is Zach Friedman from Void Star Labs. Like, he has a display that he created just mostly just for I think a teleprompter,
Mhm.
and similar kind of thing though. It's like an overlay that he then kind of scrolls through
Right.
content, that sort of idea. But it's known content because this was written, and he's kind of looking through that written content.
Right. And I think you also brought this up before the show. The big questions, turn out to be, where should the display be placed in your vision? Do you
Oh
need the
yeah.
display to be sort of positioned so that it's, sort of front and center? Can you put it in the corner of your vision? It all depends on, I
Right.
suppose, the
Yeah.
sort of use cases that you could imagine for this. And that does get into these sort of considerations with the display flex, like you mentioned earlier, and
Oh yeah. Yeah. We were
how
talking
you
about
lay
flex
it.
before the show.
Yeah, how you lay out this sort of thing into a physical device, especially if you're trying to, 3D print it. How do you assemble this sort of thing?
Right. Right. So how did you what was your process when you were kind of figuring out the flex circuits because you were kind of getting this all put together?
I think I've probably spent too much time on this to some extent because when I get into, CAD and start doing 3D models for the enclosure of this device, it's difficult to decide. I mean, it's very difficult to decide where to put things because you don't have, at least not yet, on the computer, a good simulation of what your actual eye would see as a human. You have
Right.
to
Right.
actually print the thing, assemble it, and
Humans are
test it.
squishy.
Yeah.
Especially eyes.
So the process ends up being, build something in CAD around a 3D model of a human head, positioning
Uh-huh.
things the best you can, print it, assemble it, and then just, I have an entire bin of,
Good 3D
failed
prints.
revisions which all look the same but are like
Yeah.
millimeters different in various
Oh wow.
areas,
Yeah.
in order to try to tweak this so that so the display is positioned reasonably. So
Mm.
in terms of planning, when I do the board design, I do have an idea in mind of where the display should go, how the flex is going to need to be folded to put the display in that correct orientation. But I'm also trying to keep it as open ended as possible so that I could change plans and try different things without, respinning the board.
Yeah.
So like this most recent board I did, it kind of has the display connector on the end so that the flex goes, well, this board is sort of long and narrow, 58 by 10 millimeters. And then
Hmm.
the flex, leaves the end perpendicularly to the length of the board. So if you
Hmm.
put the board sort of horizontally across the top of the front of your glasses, sort of above one eye where your eyebrow is, then the display flex can come down nicely and put the display just beside your nose. So that's what
Oh,
my current prototype is doing. But then you can also put the board lengthwise on the side of the glasses in the sort of frame by your temple, and then fold
right.
the flex behind the board, make a 90-degree turn in the flex by folding it, and then have the display come forward, kind of where Google Glass used to have it.
Right. Yep. Yeah. And then they had a prism as well. So you have to have prisming in yours as well to get like the shooting in your eye kind of thing?
So that's an interesting problem because if you do want to have a see-through, transparent display where the display is, partially artificial content and partially the real world that you can see through, you do need some sort of combiner. So people do prisms, they do like bird bath style combiners, like the
Oh,
Nreal devices. Now Nreal is called Xreal. And then there are people who do diffractive waveguides, reflective waveguides, and all of these have, advantages and disadvantages. Of course, the combiners like waveguide style things, diffractive and reflective, are very, slim and nice looking in terms of replicating a real lens that you'd find in a typical pair of glasses. The disadvantage is, well, currently they're expensive and hard for me to get my hands on to prototype, and their optical efficiency is pretty terrible. So you lose a
oh,
ton of energy by feeding more light into the system than you will get out of the system.
right. So then the battery suffers, and yeah,
Exactly, exactly.
yeah.
So most of those waveguide systems you find, they will not be using OLED microdisplays because this OLED on silicon technology is not really currently bright enough for
Hmm.
the requirements of those waveguides. So you'll see people doing like DLP things with essentially
Mm-hmm.
tiny projectors in your, glasses frames, or liquid crystal on silicon with bright white LEDs as the light source.
Sci-fi has told me that I was supposed to be getting lasers that directly draw on the back of my retinas, and I have not yet gotten that one.
Oh,
Not sure I actually want it, but that's what sci-fi told me I would be getting.
right. And there are people who do laser beam scanning too,
No way,
where
really?
where
Huh.
they'll have, red, green, and blue lasers, combine those, then have a MEMS mirror, sometimes one mirror
Right.
scanned in two axes in like a raster pattern, or two
Oh
mirrors.
wow. And then you just get like persistence of vision to you just depend on that to actually like maintain the image.
Right. So at least one of the HoloLens designs used that laser beam scanning, with various degrees of success. Some people are very critical of, the LBS designs. Some people are still going for LBS.
I honestly, so first off, I should have said up top. I'm super impressed that you're doing this on your own dollars, like just for like learning and all that stuff. I cannot believe that HoloLens still exists. I cannot believe that Magic Leap still exists. Like, how much
Yeah.
money have these companies wasted on this stuff? It's just insane to me.
Right. Yeah. And my personal view of the design is I'm trying to keep it a lot simpler than you have with those diffractive waveguides and LBS technologies. So the OLED on silicon displays are definitely the most mature display technology, which is small enough to fit into something like this. So I have those, and then I'm not using a combiner right now. The most recent idea I had was to put the display essentially right beside your nose so that as you look, so if it's in your right eye, for instance, as you look to the left, your right eye looks kind of over the bridge of your nose.
Oh
And
yeah.
in that position, your right eye can view the display while your left eye views the real world beyond. There's nothing obstructing your
Ah,
left eye. So then you end up getting this effect where,
it's like
you
an overlay.
right, if the display is off, you can still tell it's there. It's not too obtrusive though, because your brain essentially kind of makes it look transparent because of your left eye still being able to see the world beyond it. If
Hmm.
you have the display on, you can, like, convince your brain to view it pretty nicely, at least in
Hmm.
my experience. I have to try this with more people.
Yeah, I mean, and well, I think that's another thing where it's like you mentioned moving from a 3D model of a head to like an actual head, and then just the differences between people too. I look at a lot of the design decisions in a lot of these things, and just when you start to really look at a wide variety of faces, just Google human face on the internet, and like just like how much differentiation there is with pupillary distance and just
Yeah.
head size and all these factors, because people just look different, and like that actually really impacts how your experience would be too, which sucks.
Right. And I suppose with the monocular display, I'm trying also to avoid some of the issues with the interpupillary distance adjustment that other
Yeah,
headsets have to deal with if you have two displays. it,
yeah,
it's definitely interesting to try sort of wild things like using your brain as the combiner
yeah,
between the
yeah.
two eyes, like I'm trying here. Some things like that, perhaps they could be useful. It depends. In my most recent design, it really depends whether the entire optics setup can be small enough that it doesn't look too bulky being beside your nose. Because
Right.
if it becomes too bulky, it starts to come out in front of your eye, which you don't want.
Yeah,
You
right.
still want your eyes to be clearly visible from the front, so if someone's talking to you, it doesn't look like there's something
Are you
obstructing
sure you
your
don't want to
eye.
just project a copy of someone's eyes onto the front of your device and then these creepy digital eyes? I don't know what the hell Apple was thinking with that. Like it looks, even in the promo video where they like could make it look the best it possibly could, that lady looked weird. It just, like my brain was just like that doesn't look natural to me.
I mean, I suppose if you want to have, the chance to do fully immersive stuff with, high resolution
Yeah.
displays in
Yeah.
VR, you have no choice, right? If
Yeah.
you want
Yeah.
to
You
be
got
able
to
to
cover
see
up
the
the eyes.
person's eyes,
Yeah.
you have to do that.
I mean, that's the other thing too, is that like all of these things, they just look so dumb. I'm not saying yours in general, but I'm just like the Apple thing, it's very nicely done for what it was. But like HoloLens looks so dumb. And the Magic Leap looks so dumb. And honestly,
Mhm.
Google Glass looks so dumb. And that was nicely
Mhm.
designed too, I thought. But all of these things, it's just like you mess with the view of what a human normally looks like, and it's like, wow, that doesn't look right. So it's starting
Right.
from a bad place.
Right, which was, part of the motivation to just if you can get the electronics really really tiny and the display really really tiny, then maybe, it can fit in something that looks like a normal pair of glasses. But that's always, the big challenge. I suppose I find at a lot of events, even industry conferences in this area, like I was at the Augmented World Expo in at the end of May, you don't see people wearing these sorts of devices around. Even
Right.
though
Right.
here are all the people interested in this technology, no one is wearing anything around. And I suppose that's a good indication of the status of that industry.
Yeah. That's a really good measure. Yeah. Yeah. So, do you wear these at home, or do you just not want to wear them because you don't want to look stupid in public?
Actually, yesterday I was wearing them, out at a sort of social event pretty much the
Mhm.
entire time for several hours. So I'm,
Oh.
trying to wear them around to get a good idea of
Yeah, you're dog fooding,
the
huh?
comfort aspects of it. Yeah.
Yeah.
In terms of actual applications, obviously I spend so much time on hardware and then I have to be like, okay, now I have to switch into software mode, right? And come up with
Right.
some actual good applications for it,
Yeah.
or get some other people to do it, ship them some
Yeah.
hardware maybe. I might have to
Yep.
start doing that.
Yep. Well, let's start to wrap up on that. I mean, what's your vision for the future of this stuff? I mean, this is super awesome so far. I don't know if I've complimented it enough yet. I'm very impressed, Hayden.
Thank you. Yeah, the vision for the future is essentially to, well, at this point, I think the hardware prototyping is going to be on a bit of a pause for the rest of this year while I do
Hmm.
software development for this,
Yeah. Yep.
microcontroller platform, because I'm pretty happy with the status of that and its capabilities. Long term, I'm definitely going to try to continue working on this in some form. It's always an exciting sort of hobby project to pursue. I've been quite happy, so far, because in the original goal for it was really to learn about this sort of microelectronics design. When I started college, I hadn't even done like assembly of a BGA or really anything beyond simple through hole boards. So it was pretty nice to just spend a few years and now feel confident that if I want to design a board, I can do it. I can have a set of requirements and fulfill them and bring up something that actually runs software and works. In some sense, the purpose of the project is
Hmm.
fulfilled, but the long-term purpose, I suppose, would be to find applications for it. Maybe I open source some of this stuff at some point. Everyone always asks me if I've considered doing a startup related to this technology, and of course that's also a possibility.
Yeah, the downside to that is that if you start it, then that means you got to run it, and that's not the
Yep.
fun part,
Yeah,
you know.
yeah.
That's
For me, the fun part is the engineering and solving problems.
yeah,
So I'll always be chasing that. Yep.
yeah, definitely. No, that's great. I hopefully if people hear this, they can reach out and watch the video and see if there's other people interested. Yeah, it's definitely a great hobby project, and maybe more. I'm sure. Maybe I could ask this. I mean, if you don't mind me asking, if you're interviewing or have interviewed, did you bring this to interviews with you?
I haven't ever brought like or let's see. I've brought boards, individual PCBs to interviews. I haven't brought, I don't think, this like
The whole thing?
complete physical
Oh
device.
man.
I haven't like demoed it to someone at an interview, for instance. But
I
yeah,
mean,
I can.
I would recommend it. I mean, that would blow me away if someone walked in with this thing, that would blow
Right.
me away. But
Yeah, it's always the software work that gets in the way of having nice demos. I
yeah,
have to
you're
be
right,
like, okay,
right,
Aiden, stop doing hardware. Start doing
right.
software demos.
Yeah.
Yeah.
Well, and are you as you figure out what's next? Are you interested in working in the hardware space or the software space or both?
I did a lot of software work in the past for fun, and now I've been doing mostly hardware for fun. I still find both of them exciting, but I don't like doing generic application software on normal phones, normal computers, right? Normal computing systems are not interesting. I like special computing systems, robots, wearables, things that
Hmm.
require special thought in terms of what software you're going to write for them.
Mm, cool. I have no doubt that you will find some interesting places and interesting stuff to work on. Most notably, because if you don't like your day job, it sounds like you can just go home at night and work on this stuff.
Yeah. Yep, I've definitely spent a lot of nights working on it so far,
Yeah,
and
yeah,
that
yeah,
probably won't stop.
yeah. That's great. Where can people reach out, learn more, see your next prototype as that becomes available? Where can people find you online?
If I post additional like design details, they would show up on my GitHub, github.com/Aedan Cullen. I also have a Twitter account at Aedan Cullen. I've never been a huge social media person, so there are not a ton of things on my Twitter, for instance. But those are where you would watch
Well,
if I ever.
there's more and more social media networks every day, apparently. So there's
Yeah.
more
Oh,
places
yeah.
to not post as well.
Right. Yeah. Exactly. Yeah. So I suppose I would post something on Twitter or on GitHub.
Okay, that sounds great.
Future details.
Cool. Well, thank you for coming on here to talk to us about it. I'm really excited to see where you go in your career and just all the things that you work on because, boy, you've had a good start. This is really impressive. So keep up the good work.
Yes, thank you very much for having me. It was great talking about this project.
All right, we'll chat soon.
All right, thank you.